Alright, you guys, I want to review derivatives of inverse functions. From the past, I have found that these are not favorites of students, and I'll tell you they really aren't my favorite either. I have to think kind of hard. But I found this new method that makes it super easy, and I think it's worth going over. Okay, so let's just look at a couple of functions. And we looked at this before, but let's just make sure that we're all on the same page. Okay, so we know that that's going to go through 0, 0, 1, 1, 2, 1, 2, 3, 4, and 3, 9. 1, 2, whoops. Good thing I used a pencil. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So if we look at our function here, and we know that when we find an inverse, that all we do is we switch x and y. So we're going to make this. Okay, I got to solve here. So y is plus or minus the square root of x. But we said that y has to be greater than or equal to 0. So y equals x, and that is my inverse function. Okay, now remember that inverses are always reflections over the line y equals x. Okay, I'm looking for a good pen here that you guys can see. Okay, I have one that's out of ink. That's not going to work. Maybe I'll try a little marker. Okay, so we know the square root function does this. So the square root of 4, 1, 2, 3, 4 is 2. And the square root of 9, 5, 6, 7, 8, 9, 1, 2, 3. Okay, so this is the inverse, and this is the original. Okay, so one of the things that we talked about already is we said, okay, if you find the derivative, let's say we want to find the derivative, so we have f of x is x squared. So I'm just looking at the first function, and I want the derivative, and let's find the derivative at 2. Well, I plug in 2, whoops, and I'm going to get 4. Okay, so the derivative, or the slope of the tangent line right here, is 4. So let's see, 1, 2, 3, 4 over 1. The derivative right there looks kind of like that. Okay, and we talked about this before, and we know that if we took the point that is the mirror reflection of that, so let's look at f negative 1 of x, and let's look at its derivative. Okay, and that's one that I've got memorized. I could have done x to the negative 1 and figured it all out that way. But I know if I take the derivative of the number that goes with it, so when x was 2, y was 4, so I'm going to look at 4, 2, and I'm going to take the derivative, oops, at 4. Well, that's going to be 1/4. Okay, and so I want you to notice that these are reciprocals of each other. Okay, so that was the big picture when we did this. So let's see, up 1, 1, 2, 3, 4, is that if we have inverses, that you just have to switch their x's and y's, and, oops, that still doesn't make it very easy to see. You switch their x's and y's, and then you take the reciprocal to get the slopes. Okay, now again, you should go back to your notes, kind of look over those for that a little bit more in depth. Okay, well, I showed us kind of a new way on how to do this. And what it said was, what you're going to do is you're going to make two little groups here. And we're going to always start out with this. And kind of depends, this can be written numerous ways. I think I'll go with this right now. Okay, so every time you do one of these problems, you're going to start with that right there. Okay, and it's going to help us organize and make things really nice. Okay, so let's say that, let me say, I give you the problem that f of x is x squared plus 4x. Let me move this down here a little bit better. And I want you to find the derivative, or f negative 1, I should put, at 12. Now, we could go through the whole bit of finding the inverse and all that, but what if we had just the original problem was really yucky? We don't want to even deal with coming up with the inverse. Okay, so I'm just going to use that little method there. Okay, so whatever number that I'm given, remember, as far as the inverse goes, that's the x value. So those go right there. Okay, if that's the x value on the inverse, then it has to be the y value on the original function. So it goes there. Okay, so that's the key. And then this tells you what you need to do. So we need to know, okay, f of what is 12? Okay, so f of some number, when I plug in x squared plus 4x, I'm going to get 12. So x squared plus 4x minus 12 is 0. So, okay. So we have restricted our domain. We're only going to work with the positives. So f of 2 would give me 12. Okay, so the 2 goes right here. Okay, now I just bring that down here. F prime of 2. Well, f prime of x, again, I'm looking right here. F prime of x is 2x plus 4. F prime of 2 is going to be 8. Okay, so this is 2 right here, because remember, we just switched those points, a number and its inverse. This is 8, this is 1/8. And that is my solution. It's pretty nifty. Now, you got to do a couple of these to get going pretty fast, but I found like all sorts of problems. I could ask the question all sorts of different ways, and if you just use that one setup, not too bad. Okay, so let's say that I was given like something like a table right here, and let's say with this table that I was asked to find f negative 1, the derivative of that at 4. Okay, so I would have to think really hard doing it the old way. So I'm just going to go, I've got f negative 1. Okay, they want me to find the derivative of the inverse at 4. I'm just going to put a box because that's going to be my answer. So if a 4 goes here, a 4 goes there. If that's x on the inverse, it's y on the original. Okay, f of what is equal to 4? Okay, so f of 2 is equal to 4. Okay, so now I'm going to find f prime at 2. Okay, f prime at 2 is 1. The inverse would be the reciprocal of that. 1 over 1, 1. Ta-da! Easy, huh? Okay, let's say that I was asked to find g negative 1, so the inverse of g evaluated at negative 3. Okay, so now I'm going to have g inverse of g. Okay, so I always start with that. This is my answer. Negative 3. Okay, g of what is negative 3? Looks like g of 2. What is g prime of 2? Well, g prime of 2 is 2. So this has to be the inverse of that, which is 1/2. And I could put that 2 there. But that just it just sort of sums it all up for me. So remember that you have to switch x and y, and then these are reciprocals of each other. Okay? So go ahead and look back on, like I said, your notes. See if there, I got these 2 problems out of the notes. See if there's a couple that you can do using this method. And I think you'll be pleasantly surprised. That's it.